and owls need to be. Take this tawny owl, for instance. Silent flight, as we've seen, allows an owl to creep up on its prey. But it also means that their wings can operate quietly enough that they can hear that prey over their own flapping. But to see what makes owl flight so special, we need a little experiment. Starting with this pigeon. Just watch what happens when it flies across a bed of feathers. That is turbulence in action. Now here's an owl attempting the same thing. There's almost no disturbance at all. But how on earth is it doing it? Well, it turns out that owl wings have three very special features. These tiny knobbly teeth stop the front edge, creating one big whirlpool of air. Then a layer of soft, velvety feathers keeps that airflow close to the wing. And finally, that tattered back edge reduces turbulence as the air leaves the wing. So I thought, what if I could make an airplane wing like an owl's wing? Unfortunately, I could only find one place willing to let me have a go. An airplane graveyard.
I've had to improvise a bit with materials and such, but that's how it is with science. And here it is. It's got everything. The egg boxes give the leading edge that knobbly profile to break up the airflow into smaller vortices. The carpet, the texture, breaks up the huge bubble of disturbed air and reduces noise. And the trailing edge is serrated, and that cuts down on noise as well. So why don't all aeroplane wings look like this? Well, it turns out it's not that simple.
The problem is one of scale. That amount of egg boxes and carpet would just slow the plane down too much. And the serrated lino would apparently get in the way of the flaps they use for braking. So it looks like the sightseers of Saint Martin are safe for the moment. Science isn't about to spoil their fun. But all is not lost. It turns out there are smaller wings that would benefit from owl technology. It's just that they're attached to fans. And that might turn out to be even more important.
Okay, so a silent fan might not sound as exciting as a huge, furry aircraft wing. But bear with me, because silent fans will make a bigger difference than you might think. Imagine silent computers, silent hairdryers, silent vacuum cleaners, silent wind farms, silent air conditioning.
Because all those fans suffer the same sort of problems with turbulence that planes do. So, the inventors of this fan have used owl tech to break up that turbulence by adding serrations to the back edge. And the result is a fan that is very, very quiet indeed. No matter how hard you listen.
So this owl technology, copied directly from the way a barn owl protects its super sensitive hearing from wing noise, could end up making our noisy world just a little bit quieter.